Hi everyone, great to have you back on the channel. We've all faced it. Either the water tank overflows, wasting precious resources, or it suddenly runs dry when you need it the most. Manually checking water levels is not only tedious but also unreliable in the long run. So today at Maker's Place, we're building an IoT-based water level monitoring system that lets you track your tank levels in real time right from your smartphone. Now let's take a look at the components we'll be using in this build. Ultrasonic sensor. This is the eyes of our project. It uses sound waves to measure the distance to the water surface. ESP32 microcontroller. The brain of the operation, featuring built-in Wi-Fi to send our data to the cloud. Breadboard and jumper wires. These allow us to create a solderless, organized circuit to connect all our parts together. First, we mount the ESP32 firmly onto the breadboard. Now, for the wiring. VCC connects to VIN for power. Trig pin goes to D14. And the echo pin goes to D12 to handle the signal timing. Finally, GND goes to GND to complete the circuit. Double checking these pins is crucial for accurate data transmission. Here is the logic powering our system. In this first part of the code, we're setting the foundation. We define our Blink credential so the ESP32 can talk to our app and assign the pins 14 and 12 for the sensors, trigger and echo. We also set our exact glass height of 11.4 cm, which is the ruler the code uses to compare against the water level. This setup ensures the hardware and the cloud are perfectly synced before we start measuring. This part of the code handles the result and the alert. First, it locks our percentage between 0 and 100, so the data stays clean. Then it sends that live value straight to virtual pin V0 on the Blink app. Finally, the smart logic kicks in. If the water hits 100%, the system sends a waterful notification to your phone. To make this smart, we're using the Blink IoT platform. This allows us to monitor our hardware from anywhere in the world via the internet. Inside the app, we've set up a template named Ultrasonic 7643. When we open it, we get a clean dashboard showing the exact water level as a percentage. Let's see it in action. With very little water in the glass, we place our sensor. Note it's vital to place the sensor in the middle, not the edge. Placing it near the edge can cause the sound waves to reflect off the glass walls, leading to false readings. Currently, it shows 16% and the exact distance. Now, let's add more water. You'll notice the values fluctuating while I pour. This is because pouring water creates surface waves and bubbles. The ultrasonic waves reflect off these uneven moving surfaces rather than a flat level. Once the water is still, it shows 45%. Finally, the main test. As the glass reaches the top, the app hits 100%. Instantly, I receive a notification on my phone, water is full. In the real world, this technology prevents overhead tank overflows in homes, monitors industrial chemical vats, and helps in smart irrigation, saving water, energy, and money. Excited to explore more? Register your child for our IoT course at Maker's Place. Don't forget to subscribe to our YouTube channel for more educational videos.